question 3. So here we are asked to calculate the area of one of the gray segments here, this one. So I will define this area as S, and I will calculate it by S1 minus S2, where S1 is the circular section, the circular section AOB, and S2 is the triangle AOB. Sorry. Okay, so for S1, in order to calculate the circular section, we have a formula. It's pi r square times theta over 2 pi. So we can immediately strike down those 2 pi's. And r is known and is 2. So this equals 2 square times theta over 2, and then we again strike down here 1, 2, and S1 equals 2 theta. Now for S2. So S2 is the area of the triangle, and for that I can use the trigonometrical formula that says that the area of the triangle is AO times OB times the sine of the angle between the two sides, which is theta, divided by 2. And of course AO and OB are the radius of the circle, and each equals 2. So we have here 2 and 2, and I strike down one of those 2, and I left with 2 sine of theta. So the area of the gray segment, as I wrote, is S1 minus S2, which is 2 theta minus 2 sine of theta, or more nicely 2 times, in parentheses, theta minus sine of theta. So this is the answer for A. Now B, given that the area of the logo is 3.4 square centimeter, find the value of theta. Okay, so the logo is this shape, and this is the area of the rectangular. Yeah, so the area of the logo is the area of the rectangular minus 2s, where s is our answer from part A. So the area of the logo is given 13.4. The area of the rectangular is also known because the sides are known. There are 4 and 5, so the area is 20. And now we have to subtract 2s. S is here, so we have to subtract 4 theta minus sine of theta. Yeah, so I will divide this equation by 4, and I also move sides, so all the numbers move to the left side, and I left with 1.65 equals theta minus the sine of theta. And if I will take all to one side, I come to the equation with a variable theta, and we need to find theta. Now this equation can be solved graphically and not algebraically. For that we have to use the calculator to simply plot this function of theta. It's like a function of x, but it's written with a variable theta. So we can plot it using the calculator, and then we have to look where it intercepts the x-axis, because then y equals 0. So I used here another software to plot this curve of x minus sine of x minus 1.65, and we see that the x-intercept is at 2.357. So this is the value of theta. This is of course in radians, but it can also be converted to degrees if needed.